Okay, so for 5-4 and 5, because this is a combined section, so there won't be a separate one for 4 and a separate one for 5. It's a combined section. And we combined it all into one little cheat sheet. So it's the segments cheat sheet. This section is all about special segments. And so one of the first special segments is a perpendicular bisector, okay? So perpendicular, forms a right angle, okay? Intersects and forms a right angle. Bisector means to cut in half. So what the perpendicular bisector does, on one side of the triangle, goes from the midpoint straight up, and it's perpendicular right here, forms a right angle, okay? Now, each one of these looks very similar to each other. I want you to know that. So this is how we identify it. You have to look for these dash marks, but notice this one also has dash marks. So not only do you have to look for the dash marks, but you also have to look for the right angle. But don't get confused because this one also has a right angle. So perpendicular needs both the dash marks noting congruence and the right angle. Now, if we had all three of the perpendicular bisectors, so if we had one here and one here, the point where they all intersect is called the circumcenter. The circumcenter. Okay, so I got something to where I can draw on the other perpendicular bisectors. So this is just me estimating it, but let's say like this is the midpoint, so it cuts this side in half. And then if I go perpendicular to it, forming a right angle, so those two intersect right about there. And then if I put the other side on, we go from the midpoint, because it cuts this side in half and this side in half. And then we go straight up, perpendicular. This point right here, where all the lines intersect, that is what is called the circumcenter, okay? That point, it's where all the perpendicular bisectors intersect. So that's a very important thing to note, is it's once we have all three where they intersect, okay? So next up, we have angle bisectors, okay? All angle bisectors do is cut the angle in half, but we have to look for this little arc mark. If we don't have the arc mark, we don't have an angle bisector, okay? And then once again, the point where all three angle bisectors intersect, so if we cut this angle in half with the little arc mark, okay? And then if we cut this angle in half, right here, use 3 arcs. This point where all 3 lines intersect, okay, is the point of concurrency, which is called the incenter. So for angle bisector, it's incenter. For a perpendicular bisector, it's circumcenter. So circumcenter for perpendicular bisector, incenter for angle bisector. Okay, let's keep going. Let's talk about medians. Medians, they might remind you of perpendicular bisectors and angle bisectors, but it's not cutting an angle in half. Instead, what's happening here is that it's cutting the side in half and then going to the opposite, going to the vertex. So it starts at a vertex, goes down to the midpoint of the other side. So it doesn't go straight down. It goes down to the midpoint of another side, okay? So it cuts the other side in half. And then this point where this other side would also intersect, that point for medians is called the centroid. The centroid for median, centroid. If I drew on my third line, that would be my point of concurrency, okay? From the vertex to the opposite side midpoint. And you guys need to use this and make sure you're drawing your pictures, okay? Those of you guys in class, I'll have copies of this. Or if you want to print a copy of this, that's fine too. I will attach it to the assignment. But if you don't have a printer or are not in class, you can just draw this out, but make sure you're drawing it very specifically because each one is very important, okay? Next up, we have altitudes, okay? Altitude looks a little bit like medians and angle bisectors mixed with perpendicular bisectors. So it kind of is all mixed together, except for it doesn't cut a side in half. Instead, it starts at a vertex and goes straight down perpendicular. Okay, so it's perpendicular to a base. Another name for altitude is height. And then if we were to draw on, once again, all three altitudes, see if I can do this well. Kind of. Then this point where all three altitudes intersect would be called the orthocenter. That's the point of concurrency of altitudes, the orthocenter for altitudes. So that's very important here as well. Make sure you're able to identify which one's which, and identify, if you're asked to find the centroid, know that you have to look for where all the medians intersect. I also put on here mid-segments. It cuts two sides in half. This is just what we learned in 5-2, but I put on here because people tend to forget about it. So it cuts two sides in half and is parallel to the third side. We use triangle mid here, and it's half of the side it's parallel to, okay? So you can do textbook problems. The Math Excel is going to look a little bit different. There's also a worksheet on the page. I guess this doesn't make sense, but you can do the worksheet in your notes very easily. There's not a lot of, so if you're doing the textbook problems, it's broken up between 2 pages, and same thing with Math Excel, it's going to be broken up between 2 sections because we are combining 2 sections together. But that's what 5-4 and 5 are all about, all these different special segments. We want to make sure you learn them together, so that way you can see what the differences are between each one. Okay, so keep that in mind. And if you have any questions, text me on Remind.